có bài báo cáo với nội dung là ưu điểm vượt trội của trường cơ thể đa tiêu theo nguyên lý khúc xạ xoay không đối xứ. Báo cáo viên là ông Oliver Schultz, kỹ sư chuyên gia sản phẩm của công ty Teleon Surgical. Xin mời các quý vị bác sĩ nếu mà ở đằng sau có thể di chuyển lên trên để được rõ hơn. Dạ, xin cảm ơn.
Good afternoon, ladies and gentlemen. Thanks again for this wonderful invitation and to give us the opportunity here to talk today. I'm really excited, especially this special occasion, as I just heard that it was a former St. Paul's Church, and just a really wonderful occasion. And yeah, let's start. I'll give you a short introduction of the company, go a little bit to the products we have here available, and then of course you can ask questions. Yeah, it's working. So the company itself is located in the Netherlands. That's where we have our factory, and we have also some branches in Berlin. I'm personally from Berlin, and we have also, beside that one, we have also a factory now built in China. We have right now 150 employees, and and we are distributing our lenses technology in 40 countries worldwide. So here's the overview. All the green places is where we are having right now our distribution channels. And you see the red dot here on this side. This is our main market, of course, right now, because we are having also our focus on China, as they are having their own factory. So these are the home markets. So most of the world you see in Southeast Asia, we're covering up. There is a little bit in Africa, and also North America we have is Canada, and we have a few countries in South America. The company itself has a certain mission. The most important thing of our mission is our customer support. That's what we have done so many years, and that is, I think, what drives us, and that also gives us the satisfaction if our customers, and especially at the end, the patients, are being happy. Beside that, we also have some other parts which we are taking serious. For example, the sustainability. When it comes to, you want to be carbon neutral, like that's part of the goals, like many other manufacturers. So also we have that goal, and we are hopefully achieving that by the latest in 2040. Beside that, we are still having our own research and development department, where we are trying to get the best IOLs for the next generation. So I show you here now a short company video, just a minute, so very quickly.
With the Acunex, Lentis and Fentis brands, Teleon Surgical offers state-of-the-art cataract and refractive IOL solutions. We do that with passion for perfect vision. Teleon is technology-driven,
which means we can continue to innovate.
Launch groundbreaking intraocular lenses.
With our high-quality products,
we can improve our patients' everyday lives.
And it's always about integrity, moral and ethical principles that offer the confidence our stakeholders demand.
And taking responsibility
is never a duty.
It's built into our DNA.
Tomorrow's world starts today. Sustainability is at the heart of all that we do to secure the future without losing sight of what's happening now.
We are always striving for improvements
in our processes, in our use of raw materials,
less energy,
less waste, more efficiency.
To keep pushing the boundaries in refractive lens surgery, Teleon consistently maintains an intense dialogue with the scientific community.
Happy people make us happy.
Happy patients who can see a future again.
Happy customers who were able to make a difference.
By continuously improving the lives of our patients and the world around us, Teleon remains the frontrunner and game changer in refractive lens surgery.
With clear focus,
with pride,
we take care of your patients.
Unique lenses for unique patients.
Teleon Surgical. passion for perfect vision.
I think that gave you a very good impression of the factory because you could see a few steps of the manufacturing process. Also, like that we are in not only in the field of intraocular lenses, what we are doing right now, especially when I come to my next slide. Wait 1 second. Beside that, we have, there is a very interesting part which we learned from the past. And maybe you have heard about that surgeon, Vance Thompson. He was actually talking about LASIK. He's actually a LASIK surgeon, refractive surgeon, and he said that there is something they learned from that LASIK procedure, and that's the uncorrected visual acuity, what drives the patient satisfaction. And that's exactly what we are doing as well with our intraocular lenses from Teleon. Because at the end, a multifocality starts with a perfect unaided distance vision and ends with optimal near vision for each individual patient. I think when you think about it, that's something what I think most of you want to achieve every day with your patient. And in order to do that, we have a broad range of products. This is just an example here. You can see there is the so-called lentis portfolio on this side, with Comfort M+, and on the other side we have Femtis. I will come a little bit more into detail what is the difference between all those lenses. So at the end, when you look at this portfolio, there is probably, for every patient, there is a lens which is suitable. Beside that one, and just such a short excursion, we also having a distribution of other products. For example, the Lensa, the femtosecond laser, the Zepto, which is an automated, who can make an automated capsulorhexis, and the Vialux, that machine is for the minimal invasive glaucoma treatment. So Lensa, then, as I mentioned, the Zepto for the automated CCC, and for the glaucoma treatment. We also having viscoelastics in our portfolio, but that should be not our focus today. The focus is today what kind of intraocular lenses we can offer to your patients. So most of all, and I think that's the same here, most of you will probably implant monofocals, the standard IOLs. And even in the monofocals, there is already a broad range, starting from a normal spherical lens, which is in case, for example, some people prefer a C-loop design, some others prefer a plate haptic design, then going over to an aspheric monofocal lens, which of course also C-loop and plate haptic design. Then we have a special monofocal lens, which is, as we call it, a super aspheric, because the asphericity of that lens is much higher than what we have here with the aspheric lens. And then we continue, because nowadays there is a kind of a demand for with lenses with a violet filter or blue light filter. So we choose the violet filter technology, also as an aspheric design, C-loop and plate haptic. And last but not least, and that is something I have to explain you later at the presentation, the Femtis technology, which is for the automatic capsulorhexis. That means that is a lens which goes into the anterior side of the capsulorhexis. Let's come to, beside the monofocal, I think very important nowadays is, as this part of the field is growing, is the multifocal lens, the extended of a focal lens, which gives a patient much more than a distance vision. In our term, in our case, it is the Comfort lens. The Comfort is an extended of a focus lens, which we actually are the pioneers of that, because we launched that lens more than 10 years ago. At that time, unfortunately, the market wasn't there to see what we had already, so it took a couple more years before the market recognizes what we have achieved here. So with that lens, we also have something which is for every patient. And that's why we are also thinking that could be the future, that monofocal lenses will disappear, and that kind of lens, like the comfort, can be used for every patient. So how does the lens work? It has actually a continuous range, and gives you, because of its design, it can give you distance and intermediate vision. It works in a simultaneous vision principle. So if the patient focuses on a distance object, so the image will be sharp and the near object will be blurred. On the other hand, if the patient focuses on the closer intermediate object, that will be then sharp and the distance will be blurred. So let's take a look at the defocus curve. I think that actually talks more than any other pictures. The top line is the defocus from the lens comfort, and that is a standard monofocal lens. So you see already, when we start here at distance vision, which is here at 0 diopters, and with logMAR 0, that's where we have similar to a monofocal, and that's what we expect. Because a multifocal, that's what we said, uncorrected distance visual acuity, that drives the patient satisfaction. So first of all, we have the same visual acuity like a monofocal lens. And then we continue that range up to around 60 centimeters. And then the lens actually drops in their visual acuity similar to the monofocal. But that's something which we have the addition and for the patient, and that gives, when you think about it, like 80% of the daily life where patient is mostly using distance and intermediate vision. And that covers, it's already covered up with that lens. Another advantage is, in comparison to on this market right now, the diffractive optics. You know, the diffractive optics have the problem of those concentric rings, and with every ring you have a light loss. And with that light loss you are losing contrast. And I think that's something you probably have experienced with a diffractive lens, that patients in low light conditions, they have problems to read or to see well. With the comfort, you have similar like a monofocal lens, because the light transmission is almost 100%. So that means the contrast sensitivity is a very good. I'm just moving a little bit because I'm not sure it's so much here. Okay. This is the contrast sensitivity curve. And again, this shows what I just showed before. The comfort has almost the same contrast sensitivity as a monofocal lens. And that's where we can say, yes, this is something we can use that lens in every patient, because we are not losing contrast. The next thing is, and that's also I think what drives patient satisfaction, is the idea of dysphotopsias. You all know that these are the complaints what we get from patients when they experience halos and glare. This is an example where it shows in a phakic eye a comparison of dysphotopsias with the comfort. So you see that with the comfort they have over 25%, they have no halos and glares at all. They have mild dysphotopsias around 60%, and only the competitors IOL, they have a much higher severe halos and glares. So then again, we can say that's a lens we can use for our standard individual patients. Here's another slide which gives a similar message. With other EDOF lenses, you have a lot of halos and glares, and with the lens itself, you have this almost reduced to nothing. The Femtis, what I just mentioned, we will talk about that later, that will be the lens probably for the future, because you see here, there is really nothing, zero, whereas with the lens comfort, we still have a little bit of dysphotopsia. But you will see later why is that the case. And of course, when we talk about an EDOF lens, we need to have, of course, have a toric lens, so we have it as well. The advantage of a toric plate haptic lens, you can imagine, you can rotate it in both directions in order to align it, and it's more stable in the back as it has 4 haptic points instead of having 2. We have a configurator in order to make sure that you can calculate the lens. It's on the website where you can configure the lens. Then you have actually how to, you get a sheet where you see how to place the lens, and that's where you can also ordering lenses. In summary, that's what I put down here. The summary, the advantages for the patient are, of course, you have a higher spectacle independence, you have an increased quality life, and you have really extremely rare halos and glares. For you, the doctors, on the other hand, easy patient selection, because it's like a monofocal lens. You don't have to worry about much. You have very low risk of any IOL intolerance, and what we think, this kind of lens is the new standard of care. So it can actually replace monofocal lenses. Let's take a look at the next option. Let's go to a higher ed lens, which gives more multifocality to the patient, more range of vision. That's the M+. With the M+, we are coming now to a really unique premium IOL family, which has a unique optic, and we have an individual, this lens can be as individual as your patient. You will see in a minute why. The optic concept is similar like the EDOF. In this case, we have a higher ed on the lower segment, which gives, at this moment, more near vision to the patient. So we're having the same setup. We have distance vision, intermediate, but now we're adding the near vision. So when I say something about individualized, that's what we can see here. That's, we have 3 different options. So first of all, we have a 2 diopter ed lens. We have a 3 diopter ed lens, and we have one which is also called a 3 diopter ed, but it has an X on it, which we call an extra near vision. So let's take a look. And we have a little bit lower ed, 2 diopter ed. We don't get that much as near vision as we would probably get with a higher ed. We get good intermediate and far vision. The higher ed still has good far intermediate, but still the near might be not sufficient depending on the patient. Maybe the patient really needs to have a very close reading, especially probably in Vietnam, also a lot of high myopic patients. So in this case, we go to the next step, and that will be the X. Means an extra powerful reading. So in this case, you have a very close reading distance, good intermediate, but of course there is a little bit of a compromise, and that's what it shows here in the distance vision. So at the end, it depends on the consultation with the patient. What is more important? Is the reading more important? Is the distance intermediate vision important? So then you can choose the actual lens. So when we have that, when we compare the defocus curve, maybe that gives you a little bit clearer picture. Again, here's our defocus, here's our distance vision, here's our visual acuity in logMAR. So all these 3 lenses starting with a good visual acuity in the distance. And as you can imagine, when I said the X lens gives a little bit more near power, and that's what we see here on the blue curve. Because you see, when we look at 3 diopter around like 30-40 centimeters, we have a better visual acuity than within the 30 lens or even the MF20 lens, which of course goes down much further as the ed power is not sufficient. Nevertheless, the intermediate vision is similar between all those 3. Same as with the EDOF lens, the M+ family also gives a very good light transmission, so we can be talking about a good contrast sensitivity. And when we look at the halos and glare occurrence, when we compare it with diffractive lenses, especially, for example, trifocal lenses, we know that this is usually what patients see. There is a little bit of halos and glares. Whereas with an MS-20 or with an MS-30, we can have a reduced halo and glare occurrence. But we cannot completely exclude it. That is something, of course, which is very difficult when you have a higher at lens. When we talk about individualizing, then we also talk about toric lenses. And that's something which I want to show you here, how good we are in that toric lens, because we can actually have here a customized lens which goes in 0.01 diopter steps. So let me summarize that. When I talk about, usually we have a lens, let's say a 20 diopter lens, and then the next step will be a 20.5 diopter, or the next one will be 21.0. With that customized lens, you go up, for example, with a 20.63 diopter, and the same as with the cylinder correction. So if you choose a toric lens, you have also the cylinder correction, doesn't go in 0.70 diopter steps, that's what usually companies do. We also go in 0.01 diopter steps. So you can have a cylinder correction of 1.33, for example. So as individual as your patient is, these lenses can be as well. Maybe I show you that when we do the calculation. I think that's probably better to see. Here, for example, is one example of an customized IOL calculation. Here in this case we have the spherical power of 18.95 and the cylinder correction is 8.10. Another good part, and that's a good part for you, you don't have to rotate the IOL because we manufacture the IOL according already to the astigmatism. So that means you implant the lens, for example, if you would do the incision superiorly, you just implant it and you do a minor adjustment in order to align the corneal markings with the actual lens. And that's it. You don't have to do much rotation in order to align it with the astigmatism. It's already pre-manufactured. So that gives you, of course, a huge benefit. First is, as we put it down here, you have a high patient satisfaction because of the individual needs of the patient. We have a refractive design with no rings, as we saw already the benefits. And we can correct every single patient accurately. I think that's the most important thing right now to you understand what we can offer with that kind of product family. All these lenses which I mentioned, the Comfort, the M+, they're all belonging to the Lentis family. Now comes a completely different family, the Femtis. The Femtis comes a little bit from the word from the femto. You know, nowadays the femtosecond lasers, which can perform automated capsulorhexis. We developed a lens which fits perfectly to that system. This is how the lens looks like, and I will shortly explain how it works. So we have a lens which is actually for the automated capsulorhexis, the automated CCC. With that lens we can have a very precise and a stable IOL fixation. We have a perfect centration, and we have no negative dysphotopsias. So far when we talked about dysphotopsias, we always talked about positive dysphotopsias. Because usually, you know, when the lens is in the back, usually patients experience positive dysphotopsias, first of all, because of, as we know from competition, diffractive rings and stuff like that. But because of the lens is so much more posterior placed, negative dysphotopsias can happen as well. This lens is in the CCC, it's more anterior placed, so negative dysphotopsias won't appear. Let's go a little bit more into detail. So we have our automated CCC. Can be done with a femtosecond laser. There are also other procedures possible. If you want an example here, a capsule laser. It's a very small machine, not as expensive as a femtosecond laser. Fits very perfectly in every operating room. Also makes a perfect circle CCC. The other device is called Zepto. That works a little bit different, but gives still the same and perfect perfect capsulorhexis. So with these three devices available, you can make your perfect CCC. And then these are the options you can implant. You can the one which I mentioned before, Femtis EDOF lens, the comfort, or a higher ed, a Femtis M+. So what happened is when I put a lens in the actual capsulorhexis, there is something which we usually know from the lens which is in the back. You know, lenses in the back, as the capsular contractions occur, the lens will be, for example, shifted. The lens can be tilted. The lens can start rotate. And usually, you probably know that can happen. Let's say rotation can be between 3 to 6, 7 degrees, even more. And then when you're off the axis, especially with toric lenses, you probably have to do another surgery. Tilt can give a very bad impact on the visual acuity to the patient. And of course, decentration because of the lens shifting. But that lens, you don't have it. Because the lens is perfectly aligned in the CCC. That means these flaps, which you see here, they go to the anterior side of the capsulorhexis, whereas the big ones are inside of the back. So what happens is, what you usually know is, because of the capsular back contraction and phimosis, lenses tend to shift. That lens, you don't have it. You have the lens on the axis, on the place where it was 5 years ago, 10 years ago. And when I say that, I want to give you one very nice example. This is the same patient, operated 5 years ago. On the left side, implanted a lentis in the back, what we just saw, that was the lentis comfort. You see already how the lens on the periphery, you can see it, how it has been changed because of the capsular back contraction. The same patient has on the other eye a Femtis comfort. And you see here, the lens looks like as it was implanted yesterday. Nothing happens. The lens is in place, it doesn't move, it doesn't rotate, it doesn't do anything. Another example, this is something which probably some of you will think about that technology. Okay, if it's in the CCC, is it possible actually to explant if something happened? For example, this surgeon, he implanted the lens, Femtis comfort, that is this side here, and the patient came back, I think half a year later, and asked for, I want more reading, can you give me more reading? And he said, sure. Then I give you a Femtis M+, which has the higher ed. And he said it was so easy, even everyone thought it is in the CCC, I cannot take it out. It was so easy to take it out. So he explanted the lens and put in a Femtis M+. And the patient is now very happy with the near vision. To back up what I just said about, there is a study, and this is not the only study, this is one of our major studies. This is from Germany. It was a multi-center study where we actually investigated the whole lens, and this is the outcome in summary. And that's what I mentioned already. The lens does not decenter, only 0.06 millimeter, which is nothing. Rotation stability, less than 1 degree. And the tilt, less than 0.45 degrees. So that's just almost nothing. So the lens, as I mentioned, stays in place. So I think this is something for the future. It doesn't have to be right now. We still have to see how the markets develop on that one. But it is something which I think you should know about. There is something we can even make our life and patients' life much more happier. So the take-home message, as I mentioned, we have a perfect centered lens. We have no more negative dysphotopsias. And we have always the lens can be centered on the visual axis. And I think that's also something that you have to remember when you are implanting multifocal lenses, that these can be also challenging. If they are not on the visual axis, then the patient will probably get complaints. So that's pretty much it from my side. Thank you very much for your attention. And if you have any questions, then let me know. Thank you.
Thưa các anh chị, chúng ta sẽ còn một bài báo cáo của bác sĩ Xanh. Cũng thấy là có bác sĩ Lương Ngọc Ấn cũng sẽ